Okay, this is our first lesson on parabolas. Open up your workbooklets. Let's get started. Alright, parabolas, we can see used in things like satellites and torches. Golf ball is the path of a moving object, it's the parabola. That's the general shape of parabola. On the receiver and transmitter, they have a single focus, so coming in, receiver, or it's pointed to the one point, so that's how satellite dish works. And a torch comes out from that central spot and it's the light in a straight line. So it's a couple of uses of the parabola. Parabola device is single focus, this enables radiation to be received, amplified or transmitted and amplified. Here's a nice little video that motivates you about parabolas in real life. Okay, that shows the parabolas exist in different forms around the world. Okay, what we learned today is about plotting parabolas by plotting points. So the basic parabola rule is y equals x squared. So on your booklets you'll see written there in the table. We've elected to use the values of x from -3 through to +3. So the rule here says, it says y equals x squared. That means we need to square the x value. So the initial x value is -3. So -3 squared, or -3 times -3 is +9. -2 squared becomes +4. -1 squared equals 1. 0 squared is 0. 1 squared 1. 2 squared 4. And 3 squared 9. So now we have a table of values. We can plot these on our Cartesian plane here. So the point -3, 9 goes there. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. 3, 9. So now I have all these values. Now we've got to draw a line. This is different to our graphs you're used to drawing, straight line graphs, where you have normal straight line. These obviously aren't a straight line, so we've got a curve. So we draw our line, a single continuous line as a curve, not as jagged lines, not several lines, just one single line through all the points. Sometimes you find it easy to draw these if it's upside down, and then use the curve for your arm. Alright, let's have a look at the next example. This rule here is one of our trinomials we've met in the quadratics topic. So x squared minus 2x minus 8 is 3 parts of the rule. Previous example when you had the x squared. So this table can use -3 through to +5. And on the table you see we've broken the rule into 3 parts. The first rule says to square the x value. As before, -3 squared is +9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 9, 16, 25. Right, the next thing we do is multiply, as part of the rule says to multiply the x value by -2x. So we've got -2 times -3 in this spot here, negative times a negative is positive. 2, 3, 6, so +6. And -2 times -2 is +4. It's 2. -2 times 0 is 0. -2. -4. -6. -8. And -10. You'll notice there's a pattern. These numbers in this row here. In the middle term, the x term, you'll see this pattern occurs in each table we do. The pattern here, you'll notice the numbers are going down by 2, and that's the multiplying number in -2. The third part of the rule doesn't have x, so it just says take 8. So in the bottom row of the table we've got negative 8. So when I put negative 3 into the three parts of the rule, I get these numbers. To work out what the y value is, I add these together. 9 plus 6 is 15, take away 8, and 7. And plus 4 minus 8, negative 2 column, makes 0. When I put the negative 1, I put the values 1, 2 and negative 8, so that's negative 5, negative 8, negative 9, negative 8, negative 5, 0, and 7. You'll notice the values in the table are a bit symmetrical here, around this way. So I plot our values. When x is negative 3, y is 7. When x is negative 2, y is 0. Negative 1, 5, 0, 8, negative 8, sorry. 1, negative 9, 2, negative 8, 3, negative 5, 4, 0, and 5, 7. Once again, we have this classic U shape for the parabola. We draw one continuous line through all the points. Take our time, make sure it's a curve, no sharp points or anything like that. And that's our parabola. Features of the parabola, we should notice that about that lowest point there, the graph is symmetrical. It splits it in half. Okay, on to the third example. The example here is another trinomial, y equals x squared plus 5x plus 2. So we set up our table. In this case, we're going to use the values from negative 6 to positive 1. So we've got to put those x values into the three parts of the rule. So negative 6 squared becomes positive 36, positive 25, plus 16, etc. So we complete our row. Then the next row says multiply the x value by 5. 5 times negative 6 is negative 30. 5 times negative 5 becomes negative 25. 5 times negative 4 becomes negative 20. 5 times negative 3 becomes negative 15. 10, negative 5, 0, and 5. If you notice this row as before is going up in 5s because the multiplying number is plus 5. The third part of the rule has nothing to do with x, so we just add 2 all along. Okay, so then we look at the negative 6 into this rule. 36, take away 30 plus 2, so it makes 8. Next one, put negative 5 in the rule, we get 25, take 25 plus 2 makes 2. Next one, negative 2, next one, negative 4, negative 4, negative 2, 2, and 8. Got that symmetry of the values again. This one, you'll notice, is slightly different. Let's plot the coordinates. Negative 6, 8. 5, negative 5, 2. Negative 4, negative 2. Negative 3, negative 4. Negative 2, negative 4. Negative 1, negative 2. 0, 2. And 1, 8. Same shape as before. The only difference here being that we don't have one lowest point, we've got two lowest points. When we draw our curve, we draw through the points. At this point, we keep following the curve and then turn back halfway between those 2 points. We're going to come down to about here. We don't draw a straight line across, so the curve you should draw should look like this. Okay. Next thing you need to do is the plotting parabolas worksheet that's in your work booklet. 2 things you need to do. You need to do the tables, and then for each one, plot graph on the axis provided.